loaded on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we are going to be talking about variables and data types in the Python programming language. Variables act as containers for storing data values and allow us to remember a value and reuse it in another calculation, operation, or function call. It is important to note that almost everything in Python is an object. We'll dive far more into objects when we get to object-oriented programming later in the course, but for now know that an object represents one or more values of a specific type or class. Variables point to objects stored in the computer's memory and act as a way to bind a human-readable name to a specific object, so we can keep track of it in our code. Multiple variables can point to the same object. Unlike other programming languages such as C or Java, Python does not require variables to be explicitly declared before use. In Python, you can simply assign a variable a value, and Python will create that object for you if it doesn't already exist. Let's take a look at an example. Okay, let's trace through some Python code that just does some basic variable assignments. First up, we have x equals 42. Remember, the equals is the assignment operator. It's not the same sort of thing as equals in arithmetic. It means whatever's on the right-hand side, evaluate that, and then bind the variable name on the left-hand side to that object that results from that expression. So in this case, x equals 42 means that Python creates a new integer object with 42 in it, and then x is bound to that object. So x is sort of pointing at that object in the computer's memory. For our next line of code is y equals 5, then the computer creates a 5 object in the computer's memory, and y points at that. Next, if we try to reassign x, in this case we're saying x equals 12, what happens is a new 12 object is created in the computer's memory, and the old one no longer has anything pointing at it. X is only pointing at 12 now. There's no sort of memory of that past object with the 42 in it. What happens is Python has something we call the garbage collector, and that comes along and deletes any values that don't have a variable name bound to it. So if there's nothing pointing at it, it eventually is going to get deleted. So after we update the value of x to 12, there's no way to go back. So let's say our next line is y equals x. This one's a little bit more interesting. Remember what the assignment operator does. It's not equality or comparison. It's not asking if y is currently equal to the value of x. It's not asking if 12 equals 5. Rather, what this is doing is it's saying we're going to take whatever x is pointing at and we're going to make y point at that. So now y becomes bound to the value 12, that 12 object in the computer's memory. The old value that y is pointing at no longer had anything bound to it, so it was dropped. But now note that if we say x equals 4, it doesn't change the value of the object we're currently pointing at, it creates a new one. So we get a new object in the computer's memory, and x is now pointing at that. So by saying x equals 4, we're not changing the value of y at all. Y is still going to be equal to 12 if we try to evaluate that, and x is still going to be equal to 4 if we try to evaluate that. Now this is sort of a nuanced view of how variables work in Python. It sort of explains a little bit about how it works under the hood, but as an overall concept right now, you can think of variables as boxes that store values that we give a label to, that we call an identifier. So I just mentioned the word identifier, but what is an identifier? Well, an identifier is a unique name that we give to a variable or a function so we can refer to it in our code. But there are some rules that we have to follow when we're naming a variable or a function. We can't just call them anything we want. The first rule is that identifiers are case sensitive. This means that capitalization matters. For example, all of these different capitalizations of the word duck would be different variable names. If you had all of these in your Python program, they would each be a different variable name and could each return a different value when you're calling on them. Using incorrect capitalization is a common error new programmers make, and it can be tricky to debug at first. So I recommend not having variables with the same spelling, but different capitalizations in your program. The next rule is that all identifiers must start with either a letter or an underscore character. This means that you're not allowed to have variable names that start with a number, for example. The next rule is that the remaining characters in the identifier have to be either letters, upper or lowercase, digits, or underscore characters. No other character can occur in an identifier name. The last rule is that a name cannot be identical to that of a built-in keyword. Keywords have a special meaning in Python, and we can't name our variables or functions anything that would conflict with any of the names shown here. Let's try a quick activity. I have a number of identifiers on the screen right now, but only some of these are valid based on the rules we just covered. Pause the video and try to sort these identifiers into two categories, valid and invalid. Unpause the video when you think you have each identifier classified correctly.
Tapes rewind the mind, bits and bytes they all align. Screen is flicker, lines unwind. Fast forward code, let's hit rewind. Tapes rewind the mind, bits and bytes they all align. Screen is
Okay, did you get them classified? Here's the solution. I've sorted them correctly here. Let's take a look at a few of the more interesting ones. Underscore duck is allowed as the identifiers can start with an underscore, but perhaps more surprisingly, just an underscore is also allowed. The reason why is that there's no requirement that variables be of a certain length. One character variable names are allowed, so long as they follow the rules, and a single underscore does in this case. X and Y is not allowed, as that and symbol there is not a valid character for an identifier. Remember, they are only allowed to contain letters, digits, and underscores. These three identifiers that I just highlighted are all invalid as they start with a number. Recall that all identifiers must start with a letter or an underscore character. Lastly, 4 is not a valid identifier, as it's one of those keywords that's built into Python that we're not allowed to use. Another important consideration when naming variables is style. Just like when you're writing an essay or a paper and you have to follow a style guide like APA, MLA, or IEEE, the code you write should also follow a consistent style. Style doesn't impact the correctness of your code or how it will be run, but it's very important for creating readable, understandable, and maintainable code. This is critically important when you're working on software projects with other people who may need to read and understand your work, which is something that will happen commonly when you get out into the real world as a programmer. There are many style and naming conventions for code. I have a few of the most common ones for naming identifiers listed here. The big difference between these is how they separate words and handle capitalization. Again, the key here is to be consistent. It's more important that you stick to one style than which particular style you use. Identifier should also have a meaningful name, so it is clear to anyone reading the code what value they might hold or represent. It's important to find a balance between using descriptive names and names that are not too long, as longer names are more unwieldy and harder to manage while coding. As an example, let's say we want to create a variable name that will store the number of students in a course. Which of these would be a meaningful variable name to use to store this value? Pause the video and then unpause it when you think you have an answer.
flying lines in rewind the mind. Bits and bytes, they all align. Screen is flicker, lines unwind. Fast forward code, let's hit rewind. Tapes rewind the mind. Bits and bytes, they all align. Screen is flick.
And we're back. This question's a bit subjective, but I would say that variables like s, num, cnos, and num1026 are probably not meaningful enough to fully describe what the variable is storing. CS1026, number of students, is meaningful, but it's a bit long for a variable name. Unless it was important to denote that this value was specifically for CS1026, I would go with num students in this case. There's not one correct answer when you're naming your variables, but they must be clear and meaningful to the reader. The last thing I should mention about style is that Python does have an official style guide called PEP8. PEP stands for Python Enhancement Proposal. PEPs are technical specifications which provide design information to the Python community or describe a new feature for Python. In this case, PEP8 describes the guidelines for writing neat and consistent Python code. Python does not require that you follow PEP8. However, it is generally a good idea, and some IDEs will issue style warnings if you don't follow PEP8. Violating the PEP8 guidelines won't stop your code from running or working correctly, but they might mean that your code is a bit messy or not following best practices. So what does PEP8 have to say about naming identifiers? Well, PEP8 states that we should use snake case for function and variable names. It also says that we should avoid using confusing characters when we are naming single character variable names. For example, we shouldn't use lowercase l, uppercase o, or uppercase I, as these tend to look the same under certain fonts. It also says that we should only use English words and characters for naming identifiers when possible, as some systems might not display English letters correctly. Lastly, constants should use streaming snake case. But what are constants? Constants are variables whose value should never change after an initial value is assigned. Other programming languages have special ways of defining a constant and will enforce this, giving an error, for example, if you try to change the value. However, Python doesn't have this functionality. Part of the zen of Python is giving the programmer the power to do what they want, so editing the value of a constant is allowed. Instead, the only thing we can do is make a strong suggestion to other programmers to tell them that this variable should be constant by naming it in all uppercase. That is, screaming snake case. Here are a few examples of what constants might look like in Python. They're essentially the same as normal variable assignment. The only difference is that we have the variable name in all uppercase. And that is the only difference. Python isn't going to treat these any differently. Here we have bottle volume, which has a constant of 2.5, animal name, which stores a string, that's a text value, which is duck in this case, and we have year storing 2028, which would be an integer value. So another important topic we need to discuss about variables is that of data types. As we already covered, variables bind a name to a memory location that contains an object. These objects have a value and a data type associated with them. The data type describes what operations can be performed on this object, what methods are available, and how we can use that object. Compared to other programming languages, Python does do a lot of work to handle and deal with types for us. In languages such as Java or C, you have to explicitly declare the data type for a variable when it's first declared, and then the variable can never store a value of a different type. We call that approach to typing statically typed. Python, on the other hand, is dynamically typed. This means one variable can be bound to values of different types. Let's take an example to see what I mean. Here we have a variable named var, and we are first assigning it an integer value and then printing that value to the screen. Next, we're assigning a var a new value, and this time it's a floating point number, and also we're going to print that to the screen. Lastly, we assign it to a string value and then print that. All of these assignments and print lines happen in the same program one after another, and in other languages this would cause an error as the types have changed, from integer to float to string. However, in Python, this is completely fine. And as you can see in the output on the screen, we get pretty much what we'd expect. The integer 42, the floating point number 3.14159, and then the string, now var is a string. For the most part, Python determines the type of an object when it's created based on the value. Here's a table of the most common and basic types in Python. The integer type is for whole numbers, such as 42, -5, or 1337. Note that unlike other programming languages, Python does not have a set minimum or maximum size for number types. Python will manage the memory for you and attempt to allocate enough memory to store a value of any length, assuming there's enough memory to do so. The floating point type is similar to an integer, but can store real numbers. That is, numbers with decimal points, such as -1235.56 or 7.304423. You can store a whole number in a floating point type as well, but the reverse is not true. You can't store a floating point number in an integer, at least not without some data loss. The Boolean type simply stores a true or false value. This is a great way for when you're dealing with logical operations, conditionals, or storing a value that can only be this or that, yes or no, true or false, on or off, or so on. The last type here is a string. Strings are used to store text and can contain almost any character, including numbers and symbols. When we write a string literal in Python, we always surround it with quotation marks to make it clear that it's a string and not a variable name or some other piece of code. Most user input will initially be stored as a string, and we're going to talk more about strings in another video. In addition to these basic types we just saw, there are also types designed to contain other values. We call these containers, and we're going to be going into much more depth on these in a future video, so I'll only be giving a quick explanation here. Lists allow you to store a collection of values that are in a specific order. Lists are mutable, meaning that you can add, remove, and edit the values stored in the list. Tuples are a very similar idea to lists, but are immutable. This means that they cannot be edited or added to once they're created. Sets are ordered collections of unique elements. This means you can never have the same value twice in a set. So, for example, in a set of color names, you can never have the color red listed twice. Lastly, dictionaries function like lists, but use a unique key for each value. This is sort of like a real-world dictionary where you look up words with a keyword, and the value is the definition of the word in the case of a dictionary. Or if we go back to that phone book example, the person's name would be the key, and their address and phone number the value. Once again, we'll go more into depth into these later in the course. So how do we find the type of an object that's already been created? Well, luckily Python has a built-in function named type that will return the type of an object that it's passed. Let's take a look at an example. In this program here, we have a simple program that declares a few different variable names and then prints out the type of each variable. We start with w equal to true, that would be a Boolean value. We have x equals to 42, that's a whole number, so it would be an integer. We have y equals to cat, you can see it's surrounded by double quotes, that means it's a string. And we have z equals 4.523. That has decimal points, so that means it's a real number and a floating point data type. After that, we have 4 print lines. These print lines each start with the variable name, like w is, x is, y is, z is. That's just text that's going to be output to the user. And then we have the type function. What's happening here is the type function is being called with one of our variables. Type determines the type of that, and then it returns it to the print function. The print function then outputs the result of the type function. So when we have nested functions like this, the inner one's evaluated first, the value is then passed as the input to the next function that it's nested inside, and so on until a value is eventually returned, or a function does something like the print function. In this case, we see that W is of class bool, X is of class int, Y is of class string, and Z is of class float. These are all the short forms for those type names. Another important thing to know about types is how to convert between them. In programming, converting between data types is called typecasting or just casting. In Python, casting can happen in one of two ways, either implicitly or explicitly. Implicit typecasting occurs when Python automatically converts one data type into another for us. For this to occur, the types must be compatible, meaning that the conversion has to be possible and is typically the result of some operation. For example, converting an integer to a floating point value is not an issue and is done implicitly in most cases. However, converting a string into a floating point value could cause an error, so it has to be done explicitly. Let's take a look at an example program. In this program, we start with two variables, a and b. A is an integer with the value 5, and b is a float with the value 0.75. When we perform an operation such as addition on these two data types, the casting is done implicitly, and the result is a floating point number stored in C. Similarly, dividing two integers results in a floating point number, as the casting is done implicitly. Here's the output we'd get if we ran this program. And looking at this, we can see that the value as output by print C is 5.75. So C at this point in the code had the value of 5.75. And its type, as output by print type C, is a float, which is a floating point number or a real number. That's one with decimal points. We can also see the result of dividing the integer a by the integer 2 is 2.5, which is output by this print D line here. And the type of this value is float again. And this is output by this print type D line. The other type of casting is explicit, in which the programmer specifically requests that the conversion be performed. This is important in cases where casting cannot be performed automatically, such as converting a number into a string. This manual conversion is performed using one of the data type functions. Here we have a list of 3 of the most used data type functions. There's also similar functions for other types, such as list, set, boolean, and so on. The int function converts a float or string value into an integer. But it is also important to note that when a float is converted to an integer, the value is truncated and the decimal places are lost. Converting a string to an integer is only possible when the string only contains a value that's possible to convert. If this string had the text duck or cat5, the conversion would also cause an error, as these aren't integer values. The float function converts an integer or string to a floating point number. Just like with the int function, this string needs to contain a valid value for this to work. So something like cat wouldn't work, but like 1.35 would. And the last function is the string function, or str function, and this works on most types in Python and converts it to a string value. The last thing we'll discuss in this video are 2 common cases where you will need explicit casting, and this will almost certainly come up in your code. The first case is when you input values from the user. The input function returns a string value, but you often need a numerical value such as an integer or a float. The second case is when you want to add a numerical value to a string, but the addition operation does not allow a number to be added to a string. Let's take a look at an example that covers both cases. This program should calculate the cost of a meal, including the tip. However, it has some issues related to type conversion that cause it to crash. Let's try running it now and correcting the errors. Okay, so here we are in PyCharm, and we're taking a look at this program. So what this program's trying to do is it's trying to input the cost of a meal from the user, and it's going to add a 15% tip and output the result for us, so we can know what the cost for a meal is. But it contains some errors related to types. Let's see what happens when we just try running it. So I'll enter my cost of my meal as $100, and it crashes with a type error. So in this case, the type error is can't multiply sequence by non-int of type float. So this is a little bit confusing. But if we look up, we get a little bit of a tip. in that it's showing us exactly the line that's causing the error and even the character on that line. So in this case, it's saying the error is happening right here. And if we even look over, it would even say the line in our file, which is line 10. So these errors contain a lot of information that can really help us figure out when something goes wrong, where that issue is. Also, if we look at our IDE, we can see that it's underlining certain things in yellow. This is a bit of a hint. The IDE is telling us that there's a warning here that something might not quite be right. So when we hover over this, we can see a tooltip that says unexpected types float. Possible types supports index. So that's giving us a hint that there's a type error here. If we take a look at our code, we can see what's going on. So we're inputting meal cost using the input function here, but remember the input function returns a string value. So what happens when we try to times our string value times tip percentage, we get an error because you can't times a string by a floating point value. The issue is we need to cast this. We need to cast it into a floating point value. So there's a few different ways we could do that. The easiest would probably do the casting here. Another way that would be completely fine would be to just go like meal cost equals float meal cost. This would also convert it. Either one of these would be fine. You just don't want to do both. So I'll take this one out. But did we find all the errors? Let's run it again and see what happens. I'm going to put 100 in again. And we get another error. This time, it says type error can only concatenate a string, not float to string. And it's showing us this line here, this print line, and it's pointing right at that plus. If we look over here, we can see that's happening on line 18. So if we scroll down to line 18, we can see this line here, and the plus is right here. So the error is happening right here. We're trying to do an illegal operation. That's why we're getting an error. And as it says type error, we know it has to do with types. And in our IDE, we are getting a hint or a warning that something might be a little bit wrong here. And when we hover over that, it says type, unexpected float, possible string literal or string. So what it's trying to tell us is we can't concatenate a string with a floating point value. You can only use the plus operation on two strings when we're doing string concatenation. So again, we can use explicit casting to fix this. So right now, total cost is a float, but we need it back to string. So we could just call the string function right here, and that would convert total cost to a string, and then that string would be sent as input to this part of the expression, and it would add total cost of your meal, including tip, is $, to whatever the value of total cost is, and create a new string that's output by print. That includes both. So let's give this a run and see if it's working. Say $100. And it says the total cost of your meal, including tip, is $115, which is correct because we're adding a 15% tip. And we're back to the slides. And here's the corrected copy of our program. To reiterate, we corrected the program by ensuring the input value, the cost of the meal in this case, was converted to a floating point value, as the input function returns a string. We also needed to convert the total cost to a string using the string function if we wanted to add it directly to another string like this. That's all I have for you in this video. It's important to understand how data types work and how to convert between them, as this is a common problem we'll encounter when we're programming in Python. If you have any questions at all about this lecture, please reach out to us on the course forums. Thank you for watching and have a great day.